All right, we are going to get started. First of all, thank you so much for coming tonight. It is a sold-out event. We had a lot of people on the wait list as well, so I'm very glad that we are here together at this beautiful office. My name is Gabriela de Quieroz. I'm Director of AI at Microsoft, and I work with a lot of AI startups doing several different AI kind of work. But one of my main goals is to share what these startups are doing. I'm a data scientist, statistician, actually became data scientist and then worked on AI. Tonight is what we call this series is an AI show and tell. So it's a monthly event here at GitHub. And yes, please do scan the QR code so you can get to know when the next event is coming, which is going to be on May 8th. We are working on an agenda for that event, but I have to say that this event, the past event that we ran as well, were all sold out. So we always have a great lineup of speakers. We love sharing on social media. So please take pictures, share on social media. If you like hashtag, you can use AI show and tell hashtag. But make sure to share because we all need some love on social media. We need to see good stuff over there. So next event, May 8th. Today, we'll have people from Neon, and they will talk a little bit more about Neon. But also, one of our sponsors tonight, our partners tonight, is Twilio. And Anthony, where are you to talk about Signal and Twilio? Yeah, come over.
All right, how's it going, everyone? Good, good, good? Okay, cool. Yeah, we're really excited to be here, so thank you for having us. Yeah, we're here to promote an event that we're doing on May 14th and 15th. It is called Twilio Signal, and it is our annual developer conference where you have workshops, you have labs, you have a lot of technical sessions. So if you're interested in attending, feel free to scan that QR code for a discount, or towards the back room over there near the pizza boxes, there are going to be some blue printouts, not the red ones. The red ones are for 25% off, but the blue ones are for 85% off. Usually tickets are around $900, but again, we're giving away 85% discounted tickets, so feel free to scan the QR code there. And if you have any questions, feel free to reach out to me in the red shirt or Andrew back there, also in the red track jacket. And thanks again for having us. Thank you.
Awesome. Thank you so much. Another thing that I want to say is every other Thursday on YouTube, on the Reactor, Microsoft Reactor channel, I run kind of like a fireside chat with AI startup founders where we talk about their company, what they're doing. They do a live demo. They talk about the technology behind. It's an informal chat that I run as a way to show you all what these startups are doing. So also, again, make sure to register for that event. It's live on YouTube, but it gets recorded. I talked to a bunch of companies. This Thursday, I'll be talking to a company called How So, but I talked to Bria.ai, Gradle, Flip AI, Active Loop, etc. A lot of great companies that are doing interesting things in this space. Make sure to follow us on Meetup. So Microsoft Reactor is the one behind this event. They run in-person events as well as, again, online events. So we have a bunch of events. There is so many things going on that I will not say. But I'm very excited for this event tonight. First of all, because you are all here, of course. And then second of all is because it's a partnership with also the Global AI Bootcamp. So the keynote that you were watching is part of the Global AI Bootcamp. And the Global AI Bootcamp, I have some things to read over here. They are an international nonprofit organization with a focus on helping people to learn about AI by connecting local communities around the world. Their mission is to promote, educate, and advance a diverse AI community through outreach, education, conferences, events, and social gathering. So this AI bootcamp is happening pretty much all over the world, in person, live, virtually, hybrid, etc. And I want to thank two communities that I founded. One is called Our Ladies. If you know about Our Ladies is a community that I founded 12 years ago, and they are inclusive. And before I ask my speaker to come on the stage, I just have one question for you. How many people here are founders of AI, of startups? Cool. How many people here are thinking about starting an AI startup? Okay, awesome. So I want to invite Paul from Browserbase to come on stage and give the first talk of the night. Paul, where are you? Awesome.
Cool. Thank you, Gabriela. I just saw her last night. And shout out Twilio. I actually was an intern at Twilio in 2016 during their IPO, which is a crazy time to have no equity at a company as an intern. So it's okay. It worked out well, and I'm happy to be here. My name is Paul. I'm the founder of Browserbase. We'll talk about that later. But I'm going to talk about building reliable web agents in production. You could cut the web out. Let's talk about building reliable agents in production, because that's also hard. And has anyone here heard of a web agent before? Maybe a show of hands. Anyone know what that is? OK. Some people on Twitter, for sure. Great. And then has anyone here heard about Browserbase before? A show of hands. That is crazy to me. Well, what Browserbase is we are building browser infrastructure for AI agents. So we make it easy for your AI application to go out and browse the web. We generally power web browsing capabilities for the best AI agents, AI applications, or even non-AI customers. We power people like Perplexity, but then we also power people like Western Dairy Transport, a 54-year-old dairy transport company that hauls milk back and forth. And their first engineer they ever hired, the thing he got was Browserbase. So AI is escaping Silicon Valley, right? It's not just at the hot, bleeding-edge startups. It's in middle of America, helping companies do interesting things. And Browserbase is one of the things that power that. But let's talk about web agents. And this is a thing that I've spent a bunch of time on. I want to kind of describe what is a web agent, how do they work, how to make them work well, and if I have time, and maybe I'm going to stall so I don't have time. No, if we have time, we'll do some live coding too. But what is a web agent? So a web agent, we all saw OpenAI's Operator. It is a AI agent. It's some agentic software that can make decisions, that can go out and browse the web. So this may be, hey, go order me a bagel at my local bagel shop nearby here. You're going to have to go to their website, click their form, and order for pickup. Book me a haircut at my barber. My barber does not have an MCP server, so it's going to need to go through the web browser. This is an AI application that's going to go use a web browser to either read or write data to a website. And there's a bunch of projects that have already existed that really kind of pioneered the space. It all started with the Web Voyager paper way long ago. Adept did a lot of interesting stuff here. Of course, OpenAI's Operator, Proxy by Convergence, H Company, all companies that have been really thinking about how can we make it easier for AI to browse the web. The future of software is software doing work for you. It's software that's going to go out and interact with you in your day-to-day life. But most of the work that we do is in a web browser on a website. So if we want AI to be able to go do work for us, we need to give AI the power to browse the web. That's what a web agent does. And Web Voyager really kind of pioneered this thought. I actually really think it pioneered a lot of stuff on agents too. It was very, very early. They had this idea that if we take a screenshot of a website, maybe extract some information to the HTML elements, and let's do kind of chain of thought prompting. Remember that? Chain of thought prompting. Say, what do I do here to achieve my goal? And then take an action on a website. You can build this kind of AI-controlled browser. There was a lot of other interesting stuff happening here too. There's this thing called Vim GPT, which is on GitHub, where they put Vim bindings on each of the elements and then said, pick the Vim binding that we should do to take our action. But this was one of the earlier papers here. That was really inspirational. And they also published a great eval data set that probably should be replaced at this point, but it's the benchmark for a lot of web agents out there. Can they do web tasks on your behalf? And I want to say that there's two types of web agents that we see at Browserbase. Browserbase powers a lot of web agents. We don't offer one ourselves. We just make it easier with our web browsers. But there's vision-driven web agents and text-driven web agents, right? Two different paradigms, two schools of thoughts. and some overlap. But vision-driven web agents use screenshots. They're taking screenshots of web pages, passing them to a model, maybe GPT-4o, maybe something else. They're often augmenting the screenshot with like a bunch of boxes. They're saying, hey, this button is button number 1. This button is button number 2. Which button do I press? And then the model says, click button number 1. And then from there, your code finds button number 1 on the page based on that screenshot and clicks the button. Text-based web agents, a little different. They actually generally use HTML as the context. So they're putting in your full-on page. If it's Hacker News, it has all the divs and all that stuff. And they're saying, what do? I want to click the login button. Here's my full HTML. And then that returns either like an XPath, which is like a path to the element on the page, or maybe it does code gen, returns like Playwright, Puppeteer, Selenium code to actually click the element. Pros and cons of each, like vision agents, generally more reliable for like really complex pages, like HTML. If anyone writes React here, pages can get really complex. Text agents, a little bit cheaper, less inference-driven, and it's easier to reuse the outputs so you can cache those versus screenshots. Here's an example of like set a mark prompting on a page. You can kind of see the boxes have numbers on them. This is from a paper. I tried to cite the papers. Check them out. Set a mark prompting on images allow vision-driven web agents to go navigate the web. Kind of cool. And then this is more of like what we see with DOM or text-driven web agents, where they're often taking the HTML and they are doing some processing. Like maybe we're stripping out, like you have a bunch of stuff in here, like, do you really need to know that it's M3R, like three margin? That's Tailwind, I think, right? Maybe we can like remove all the CSS classes just to give less context. We all know with LLMs, less context generally is more accuracy. You gotta be smart about that though. You don't want to take out too much context. There's also other things where people are using like accessibility trees. We see this more at the OS level, but it's definitely happening in the browser level. You can take the ARIA tree, accessibility tree, and get like this kind of cool representation of the page in a much more straightforward way. So people are doing a bunch of hacks to transform this. It's not generally just like a pure screenshot or a pure piece of the HTML. It's generally modified to get better results for the LLM. But there is this kind of newer type of model, right? It's computer use models, and computer use models are actually trained on UI data. They're generally vision-driven, but you're not doing set of marks prompting anymore. They just kind of already know this is the thing I want to click. And they, OpenAI launched a computer use model. We partnered with them on that launch. Anthropic has one. UiTars is an open source one. It's trained on UI tasks and web trajectories. And the way they do this is by having a person, I'm not going to go through all this, it's a little intense, good paper though. They have a person go through this kind of workflow, and they're capturing all this data on like, how are they making decisions on what pages to go to? They may give them a prompt like, go to Amazon and buy something, and they're recording these trajectories, like they go to step 1, step 2, step 3, and using that to kind of train the model to have better results, not only in the reasoning layer, but also in identifying UI elements. So computer use models have really kind of changed the game a little bit, and there's really a place for all of these when building web agents. But we're talking about building reliable web agents. We don't want it just to go buy Amazon. We want it to go work everywhere. And that's where there's a lot of interesting ideas that come in. First of all, I want to kind of bring up this idea of like, do you need a web agent or do you need a browser tool? If you're building an agentic application, you probably already have some reasoning or some agent loop already built into your application. And I'd argue that you don't need to rebuild a whole web agent. You actually just need browser tools that you can call. This just makes a lot more sense. The reasoning layer of your application needs to stay separate from your tool calling layer. You can think of tool calling and agents as like little mini agents. You're handing it to a function, it's doing its thing. And as atomic as you can make those tool calls, you're gonna get a lot more reliability. An agent is basically a multiplication of the probabilities of all the corresponding tool calls. If you have one tool call that's unreliable, your whole agent's gonna suck, right? So as much as you can make those tool calls, in this case, maybe it's like browser.go to Google, browser search, Browserbase. As much as you can make those tool calls atomic, you can actually get a lot more reliability and defer to your reasoning loop that's separate in your existing agent to actually kind of control the longer context and state. So for me, I really kind of want to think about like, how can I avoid giving my tool call a single prompt that might take multiple actions, and instead having it have one prompt mapped to one action, right? It's more deterministic. And that's the big thing we're looking for in agents. I know agents are agentic, they're not deterministic, but you can make them more deterministic. If you want a reliable agent in production, especially a reliable web agent, you don't want to give it a prompt to go order me a new camera, and it's going to go to a different website every time. You kind of want to constrain this as much as possible just to get that reliability up. So instead of thinking about web agents, you may want to think about browser tools. Operator is an example of web agent. You kind of ask it to do something. It kind of does whatever it will to get that task done. Versus like Stagehand, which we'll talk about later, that's our open source browser automation framework. It's much more of a browser tool, deterministic atomic actions. We can ask about that more in the Q&A. Secondly, evals, okay? Hot take. I think most benchmark are fake news. If someone says they're state of the art on something, they probably mess with that data. So benchmarks are fake news. I don't think you should discredit them, though. They're helpful. They're a helpful data point. But if you're building on top of any sort of third-party library, any sort of framework, you still need your own evals. You can't trust that a model that's state-of-the-art is state-of-the-art for the way you're using it. We use Brain Trust. I love Brain Trust. You need to build your own evals, even for your own agent. And that's going to help you tune prompts and understand things. So I really recommend building your own evals, even if you're building on top of somebody else's agent tool. So model, it helps you also, like, for us, we know that, like, when 3.7 came out, we ran our own evals on it, and we saw, oh, actually, 3.5 Sonnet's still really good for web agent stuff. So really think about building your own evals. Secondly, you need observability. So if you are going out and you're having a browser tool go do something for you, what if it breaks? What if your agent doesn't work? You want to make sure you can actually record what's going on. And in web agents specifically, logs aren't good enough here. You need screenshots, you need session replay, you need to see the web as it looked to the AI. And what we have at Browserbase is this kind of like nice session recording. You could build this on your own with like Playwright Video Recorder. But generally, you want to make sure you're recording what happens with the web agent so you can see exactly what went wrong, and that's going to help you further refine your prompts. This is especially nice with eval loops, where if you have an eval that's not performing well, you can watch the replay and maybe kind of reason a little bit better about what the prompt should be. Secondly, you need like human in the loop sometimes. Like if you're building an application that's going out and browsing the web, it may have to do 2FA, it may have to enter in a password. This is where you're going to need to have a human come in and take over. So design your applications knowing that there may need to be some human engagement. This is what you kind of saw with OpenAI's takeover mode, where you can actually help it enter your credit card information or help it enter a 2FA or solve a CAPTCHA. Some sort of human in the loop is still necessary for reliable web agents. And I definitely would think if you're building a new startup, there's a lot of new founders here. If you're building a startup, think about how human in the loop can be a part of your agent early on. It's going to be really easy to do it now versus like having to go backwards to it later. So I think we're good on time, right? How am I doing? Done on time? Okay, let's do some live coding. Absolutely. All right, I'm going to show you a web agent that we're going to build right now. Okay, here we go. Let's switch. Can you hear me? Okay, sweet. Let's go over here. Not that. This bad boy. So I'm going to go ahead and do this really nice command, npx create browser app. And what that's going to do, it's call it demo. That's going to create a simple web agent using our agent framework Stagehand. We'll use Browserbase for this. Now, the thing about Stagehand is that it's for building bigger web agents. If you already have some sort of agent you're building, but you want to add web browsing capabilities, Stagehand is kind of perfect for that. So if we cd demo, I'll go ahead and pull up the code really quick and hopefully not leak my end variables. If you're recording and I leak them, just blur them out if you don't mind. Thank you. And I still use cursor. Maybe I should switch to windsurf. We'll see. Okay, let's pull this up really quick. So can I make this bigger? Yes. Too big. So you can kind of see here that this is different from any like web automation script you've seen before. We use this natural language to say, take an action on this page. And this is much more reliable and durable than if you were to use traditional web automation where you're saying, click the specific button. The search box can change. It can change to explore or something else, but semantically it could be the same thing. And then we also have this observe thing where we can say, hey, let's take an action and actually observe if that's possible. Where's that action going to be? We can act with a cache. So if you generate an action, once again, it's a text-based web agent, you can persist these actions and save them in memory and reuse them. So you don't have to generate every time. You don't have to use inference every single time. And of course, you can extract data out of the page, once again, using natural language, but with a structured output that we're all kind of familiar with. So if we hit npm start, it's kind of lame that it goes to our docs, but we'll live. Let's click this bad boy up. This is going to go ahead and open a browser in Browserbase. And you can see it's going to look at the page, click search, hopefully type something in. This is looking at the page. Tell me in one sentence what's so good about Stagehand. And what Stagehand is used is you can work this into your agent. You can add web browsing capabilities into your agent in a controlled, deterministic way using this kind of lower level framework. You don't want a framework that's going to do it all for you. You want a framework where you can actually control it piece by piece. So Mitlify will go ahead and summarize this for us. Shout out Mitlify, love the docs. And then we'll extract that out and hopefully return it right here in our text. You can kind of see some of the stuff here. So I'll let this kind of wrap up. There's a summary. I'm Paul. We're hiring at Browserbase. So if you want to come join this really cool browser infrastructure company, we'd love to talk to you. But I'd love to do some Q&A if we have a few minutes for it. So I'll hand it to Gabriela. Thank you all.
So we have a few minutes for 2-3 questions. Who has a question here?
Check out our cube. I just built a new cube. It's way bigger. Cube V2 up here, actually. So, okay, what's your question?
Wonderful presentation. I was wondering, you mentioned observability and the need to add a human into the loop for understanding. How do you do the workflow for, how the human understands how the process the agent went through?
Yeah, for agents, you can add like a, ask for help tool. So, maybe you're building some workflow into your application where they can text or email or Slack message or push notification your customer. So if you give your agent a ask for help tool, it can use that in a kind of agentic workflow. Once again, this is the benefit of you owning your reasoning layer. You get more control over like adding in new tools like human in the loop types of tools. So it's a tool call that then triggers an interaction with a person. The person then does it.
So right now, when you ran the code, is there anything in there or?
There wasn't, but we do offer this thing called the live view where you can embed the browser in your application. Let's say the human needs to take over and do some sort of action like enter their credit card. You can pop open this iframe and they can interact with the browser. Most people doing browsers have some stuff here like VNC, and that's because we call it a live view. OpenAI calls it takeover mode. So you should make sure that if a human does have to interact with something that's hosted in the cloud, there's probably some interface or way to do that. In that case, we call it our live view.
All right.
Cool. Thank you.
Just one follow-up. Is this powered by any OpenAI models?
No, this one was using Claude, but we're not a model person. Yeah, we'll spread the love a little bit on questions. Click a new cube.
Hi. Is there anything I need to do to make my website accessible to a web agent that's different than making it accessible to a human who's browsing my website?
Okay, this is a hot take of mine, but I actually think that humans are going to be the slow ones, AI is going to be able to browse the web just as well as we do. So I really think if you think about best practices for people, it's going to be just as good for AI in the medium, longer term. Short term, use accessibility standards. You actually all should be using that. We love accessibility here. It's good for people. It's also really good for AI. So as long as you're following popular accessibility standards, you're going to get most of the way there.
Do you have specific use cases that are most profitable for your customers that are using those agents?
Yeah, this is just maybe more me as a founder. As a founder, I love to build things that I sell for pennies that my customers can sell for dollars. That just ends up being like really great businesses. And Browserbase is in the business of helping people build applications that save people hours. And that just ends up being a very profitable endeavor because our customers are replacing tedious time spent by people that can cost tens or hundreds of dollars, and they're paying 10 cents per hour for the browser to run. So use cases here is really like anywhere that people are doing tedious work online, form filling, research agents, Browserbase can kind of help power that. So I can talk more about use cases later if you want to come find me. I'll tell you all about our crazy customers.
Awesome. Thank you so much,
Cool.
Paul.
Thanks, everybody. Appreciate it. Browserbase.
All right. We have the next speaker, which is Erik. Erik, come in.
Hello, hello. Give me like 5 awkward seconds to plug in here. Yeah.
Well, if you are looking for Azure AI credits, free credits, please talk to Rob over there from Microsoft for Startups. We give a bunch of credits that you can use on Azure, and from infrastructure to AI models and a bunch of other benefits, so go and find Rob.
Okay. Awesome. It did take me more than 5 seconds. Felt the pressure. All right. I'm going to talk about measuring agent experience. It's actually a super great follow-up to Paul's great talk, using isomorphic systems of LLMs. I just put a scary word there. It doesn't really mean anything special. We'll talk about it in a second. But I'm Erik. I'm an engineering leader at Cisco Meraki. I have worked on a couple pre-LLM AI startups, so I think that makes me super old in the space. I also teach lecture on a non-technical course called AI and Society that I developed at universities. I play a lot of guitar and I like to hack on stuff. And what I'm going to talk about today is just something I've been hacking on for the last few months. It actually came out of human accessibility stuff where I was trying to do some chaotic good of building like an agent that could give recommendations to sites on how they could add accessibility features, because I felt like otherwise no one's going to do it if someone just doesn't hand them the code. But while doing that, I kind of stumbled upon maybe a common problem, which is what models, what tools should I use? How do I orchestrate them? And I was just like swapping in and out, in and out. I was like, there's got to be a better way. So we'll get into that in a second. But the main thing I want to say here, this thesis is about agent experience and why it's important, is that differentiating on agent experience is going to be, or is already, the most powerful vector for disruption right now. As Paul was talking about, like agents can be very fast. They can do a lot of tedious tasks in swarms. So differentiating on the agent experience, like your service, your website, how it serves agents is a huge differentiator. But before getting into that, this is what poor agent experience looks like according to ChatGPT. So it's a bunch of LLMs trying to accomplish some tasks, and they're just not able to do it. Clearly, they're not using Browserbase. But if you have not seen this, the agentexperience.ax site, definitely check that out. Some really interesting materials there. Basically, the TLDR is that this is a very, very new field, and that LLMs.txt or having an MCP server doesn't automatically mean that you're serving agents well. There's a lot more to it. So just a show of hands, who here has built like an AI agent? Okay, okay. Who here has tried to prompt ChatGPT or another model with questions? Okay. Who's got it to be reliable all the time? Okay, cool. So we have some experienced people. Also, I have a very similar hot take to Paul. Just met you, but I feel like we have a lot in common. This is a benchmark. Anybody ever see these like benchmarks before? Yeah? Okay. So I have a similar hot take that they don't really matter to us because we tend to hyper-focus on these. Like a new model comes out and it's like, whoa, I did this on this benchmark and whoa. But like if we're building agents or we're building like tools or software with LLMs, those don't really matter that much because we're not building agents for AGI. We're building agents to accomplish a specific task. So we care about how good is it at this specific task. Just a shout out to Convex. They have an open LLM leaderboard specifically for their service. They also have an open set of evals as well on GitHub for this. I think this is kind of the most state-of-the-art I've seen in terms of agent experience, and at least in the open source world. But you can see here that they've come up with their own evaluation criteria, their own benchmarks for how good these different models are at using the Convex platform. So if you wanted to build an agent that's good at working with Convex, you'd probably look at something like this. So probably many of you have experienced the magic of LLMs, the magic of agents. You get this feeling like, oh my God, it worked. This is amazing. And we call those vibes. And this is what it feels like, or what the reality is that you experience that magic and then it doesn't scale, or you're just like, oh, just do one more thing, and then the whole thing comes tumbling down. You start thinking of like, which model do I use, or models, which tools, which frameworks, which prompts? Should I do Python? Python seems right, but maybe TypeScript. Should I like use a cloud service directly, like hit an API? Should I just use my own compute? And of course, like you already know, you should use Browserbase as stagehand, Neon for your database, Microsoft, Twilio, GitHub, OpenAI. Shout out to all these people for sponsoring or speaking tonight. But I want everyone to rest assured that it's not just you and it's not just on you. It's a multi-sided problem, or it's a platform problem. And like I was saying before, if just because you have like a website or an API or even your own MCP server that you've spun up, agents are going to be using them. And the best way to think about agents is that they are customers. And the customer is never wrong, right? So instead of thinking of this of like, which model should I use, we can also think about it as, how do I make my service or my website better for this new kind of class of customers? And I think this is not really a hot take, but if you think this through, that some sites, services, docs, anything, are better than others at serving models, then it means that we're going to enter into a world where if your competitor is better at serving these new customers, you're in trouble. So this is why kind of it's important to take seriously. And what I'm going to try to propose here is that we can make both the development process for building agentic flows, whether they be fully agentic or workflows, we can make that easier and cheaper. And we can also make services better for agents with one solution, which is focusing on and measuring agent experience. So this is where I'm going to throw in this isomorphic term, just to sound very fancy, and also because this is a little too wordy to say, towards a service optimization framework based on isomorphic intent evaluation via polymorphic model and tool selection. Because I'm a nerd and I wanted to write an academic paper, that's what I would call it. But basically all this means is that you can run the same intent anywhere, and you can eval automatically. You can run different models, open or close, local or cloud, supervised or unsupervised. Ask me later about unsupervised. I think that's a really cool thing. And you can get scores from that. So what I'm trying to hack on for myself and see if other people are interested in, whether I should like build this as like a larger platform, is something that you could use as a web dev to build new kinds of suites of tests that are intent-based rather than end-to-end test or unit test and integration tests, to see if an actual agent can accomplish the intent that you wish that they could on your own website. Whether you're building an MCP server or a client and you want to make sure that you're either building it well for multiple models, or you're building a client and trying to choose which MCP server is best for you. And yeah, anyone really wanting to build this out further. Yeah, so anyway, if you are interested in this, if this is interesting to you at all, please go check out vibecheck.ax. I don't know, try to come up with a cool name. If you send me your email address here and a website that you want me to vibe check to see how the agent experience is, I'm just looking for a lot of different sites to test out. And yeah, please check it out. That's it.
Thank you, Erik. We have some time for questions, if you don't mind. So anyone has questions for Erik in the audience?
Yep, you wanted us to ask you about supervised versus unsupervised.
Thank you.
As well.
It comforts me to know that at least one person was looking at that. Yeah, so the unsupervised, like I said, I was just like hacking around. I like to hack on things, procrastinate. And what I realized was that kind of an unsupervised flow makes a lot of sense for agent discovery problems. So I think that will be like an area that we get into soon, is like if you wanted to accomplish a certain task on a certain website, let's say like buy a flight, you can define that in a very like supervised way. So you can say like go to Expedia, search for this city to this city, and find me the cheapest ticket, right? But an unsupervised flow could look more like find me the cheapest ticket. And it's not specific to like what website you should go to. So I think that as things mature a bit with the agent experience, that will become something that is a lot more affordable to kind of run. But it was super fun, both for like, tell me what the intent of a specific website is. So like, let's say, there's someone here who they had like nice rate limiting or whatever on their website, so it didn't take it down or anything. But I slammed their website a little bit, just kind of trying out like a lot of this different stuff. And one of them is like, what is the actual website for? That should be super obvious, right? Like, what is your website for? And it's actually very complicated because we put so many different elements on a page, and like that's distracting for humans, but it's also extremely distracting and expensive for models. You're throwing a bunch of kind of noise into the context. Yeah, so the unsupervised is sort of like, how do we optimize a specific site, or how do we kind of discover across many different sites, like a nice optimum there for stuff. So, yeah.
Thank you, Gabriela. Actually, I think my question piggybacks on the previous one. I think it's related. I was wondering, so I looked at your vibecheck.ax website, which has like 2 input boxes, the URL and the contact. So I was wondering, how do you figure out what makes a website agent-friendly?
Yeah, that's like the $1 trillion question. So vibecheck.ax, ironically, is not vibe checked. I'll do that right after. It's just a form. The HTML is like, it's like 30 lines or something like that. So with like an iframe, but simple, like as little noise as possible. Is very helpful. There's like the LLMs.txt, there's like convert it to Markdown, like these kinds of things. But I think those are like kind of hacks around it, where if there's probably a world in which we will have services that are like built agent first, like to serve agents first, like I think we're seeing with like MCP and things like that. I think it's really going to be around discovering like what actually works, and it's different, wildly different for different models. Like when I try like Llama family models or DeepSeek models, OpenAI, Claude, like there's a big difference between like with task-specific model families and like the cost, and it's some kind of meeting of those things, I think, that will help us understand like how do you make a website full enough, but also simple enough and cheap enough for agents to access.
Okay, thank you.
Yep.
Awesome. Thank you so much, Erik.
Thanks.
So now we have Mahmoud from Neon to give the next talk.
All right. So sorry if I sound a bit weird. No one told me San Francisco, like it's cold, rainy, windy, hot, all in the same day. So sorry if I sound a bit weird. All right. So my name is Mahmoud. I work at Neon. We're sponsoring the event. We do managed Postgres, so databases. I build demos, do videos, talks, docs, you name it. And I mostly hang out on Twitter, so feel free to reach out if you have any questions or you just want to chat. And yeah, So how many of you here are familiar with this interface? I hope everyone. So this is the typical experience with all of the AI LLMs. You have a text box, you write a prompt, and then you wait for a little bit, you get the output, and you're happy. There are two problems with this user experience. So the first one is you have to initialize the conversation. You have to write your own prompt, find like what is the prompt that works best, add your own files, PDFs, all this sort of things. And you can only do one task at a time. So you have to think like, okay, I have a problem. Let me try to get the LLM to do it for me and to fix it. So this is kind of why everyone is talking about agents, because agents, it's all about delegating tasks, running things in the background where you don't have to initiate the things. It's like things just happen in the background on their own, where AI does stuff for you. So there are a couple of use cases that are very common. You have coding. So maybe if any of you have seen things like Devin, maybe you're just like, hey, do this task for me. And it has a bunch of tools. It will go work in the background, get back to you. You can be like, okay, this is great. And you can kind of like iterate. Support is a common use case. So when you have an incoming support ticket, then what will happen is, like it's going to maybe suggest a response or maybe even take some sort of action. So it's like someone's like, hey, this tool sucks. I want my money back. It will like automatically refund. And yeah, deep research. This is also a very, very cool use case. You give a topic and just the thing just works in the background, does all the research for you. And there are more and more use cases soon. So who here hates email? By show of hands, like, you have your inbox, emails piling up, you just receive emails. I know I do. So I wanted to build a tool that can help me kind of just solve that problem. And this is like a personal email agent. And what I wanted to build is just an agent, which for me, honestly, it's like just like a function that does some things in the background. And I wanted to summarize and label incoming emails. So at a high level, this is how it's going to work. So I'm going to have an email address, and this email address is going to be set up in a way where when it receives an email, it's going to forward it to a webhook endpoint. And a webhook endpoint, you can just think of this as an API endpoint that's going to receive like a payload. So in our case, it's like the email content. So who is it coming from? Like let's say if there are any sort of attachments. And we're going to have these just forwarded to just a service, really. And in the service, we're going to write a logic where we can use AI to summarize and label the emails. And then I want to store them in a database. And this way, I can then later display it. Now, at a high level, this is kind of just the architecture. You can kind of do in the AI service bit whatever you want. So maybe you can integrate with other services. Maybe you do something related with browsers. You can kind of do whatever you want, really. So demo time. All right. So may the demo gods be with me. Let's say we have this event description, and that we received it as kind of like an email. This is kind of tricky to do with one hand. And I'm going to create a new email. And let's paste it. And let's just say, hello from GitHub. And I have, I'm using Postmark, which is an email sending service. And they allow you to have an email address you can use to receive emails. So essentially, all we need to do is we get this email address, and then there is a URL that I already added that it's going to essentially forward the email contents to. So all I need to do is paste this, hit send, and now, so I have this project. It's open source. I'll link the repo in the end. It's actually running in a GitHub code space, and I'm actually just proxying localhost with like a cool tiny service. It's called like sme.io. But essentially, here we can see that I received like an actual request payload to an endpoint that I have set up. And if we can actually go to the app and it's running, what will happen here, so this is the default state, is like when there are no messages. when I refresh, we have the thing. So thank God it worked. Okay, so this is the summary, and these are the labels. And this is actually the subject line that I wrote, and I have the original email here. So this is kind of like the demo, and now we're going to look at some code and to try to understand how it all works. So this repo right here, it's simply a full stack app. It's using React Router. If any of you are familiar with the framework, it allows you to both run a front end, like you saw, but also allows you to run backend code. So all I have really is just 2 files. The first one is just the homepage that you all saw. And all I'm doing is I'm just making a request to my database to fetch all of the emails from like a messages table that I have. And then I'm just rendering the user interface. And this is using React. And on the back end, which is the more interesting piece, I have this one single API endpoint. And I'm doing a bunch of stuff here. So I'm going to tell you exactly what I'm doing. So the first thing I'm doing is I'm doing some schema validation, which is like a best practice. You just want to check the contents of the incoming JSON. And then there's like an authentication check. So when your app is live and you have this webhook endpoint, technically it's a public endpoint. And you don't want just anyone to spam it with whatever. So you have to have some sort of secret that's included. Now, there are kind of 2 ways to do it. But one way to do it, kind of like the old school way, is with like HTTP basic auth. And the way it works is in the URL, you can include a username and password. And this way, what I can do on the back end is actually check that I have, I can essentially check if the incoming username and password matches an environment variable that I set. So this is how you would secure it, and you would prevent anyone from essentially like pinging it. Now, there's a missing step, which is you need to also add rate limiting, so like no one still spams it. And after that, I'm just validating the incoming data. And after that, this is essentially all of the AI piece. I have a prompt. The prompt asks me to just generate a summary, and I pass the incoming data that's in the email. And then I'm saying the summary should be 1 to 2 sentences and only generate 1 to 2 labels that are only relevant to the email. So this right here, this single API call, I'm making an API call to the OpenAI API using a library called the AI SDK, which is maintained by Vercel. Shout out to them. And all I'm doing really is I just pass the schema, which is like the way I want the LLM to respond, and I'm passing in the prompt. So the schema here is what actually allows me to return a structured output. So the way it would look like is I will have an object that's JSON that's going to be of this shape. And this is what allows me to just then store it in my database. And this is I'm just inserting into a messages table, and that's it. So at a high level, this is kind of like the hello world example. Typically, because you are running a bunch of steps here, if you want to make this production ready, you will need to have some sort of retry logic. Maybe you will have fallbacks for different LLMs, because maybe OpenAI is down, maybe Anthropic is down, so you'll need to write that logic. And yeah, of course, like previous talk mentioned, you will need probably some sort of evals, observability. But at a high level, though, this is kind of the architecture that you could use to build an event-driven system that allows you to run a bunch of AI stuff in the background. And yeah, this actually is a workshop. So if you go to this URL, you will just find that it will take you to a Git repo, all of the details and contents, much more in depth, all the steps, you can follow it. There's like exercises, solutions, so feel free to check it out. And let me just go back. And yeah, so this is the URL. And yeah, thank you. So this is kind of how you build your own email assistant.
Thank you, Mahmoud. Can we go back to the URL, because it was super quick,
sure.
so people can take a picture. In the meantime, does anyone here have questions?
Yeah, any questions?
Awesome.
Thank you. I'm a little bit concerned about some sensitive information, like how the agent dealt with this, and how can we ensure it protect it? And will the data be stored as new? And will the data be used for future training?
So it's kind of up to you. So with this use case, the way it works is I'm using OpenAI's API, but if you want, you can technically swap this out with any other large language model. And for what you do with the summary is kind of up to you. Like for me, I just stored it in a database as raw text, because this is kind of my own personal thing. But if you're dealing with, let's say, you want to turn this into an actual business, then things might be a little bit different, and it depends on how you want to handle it, really. But you kind of have full control. So for me, the goal really is just the high-level architecture, where you can essentially just have a way to forward, let's say, a payload, and then you can handle it. And then you can just reuse the same concept to build the support agent. It could work the same way, and that's kind of how it works. But yeah, go for it.
I saw that you used Neon for this project. How does it stand against other databases in this particular use case?
So for this use case, I'm just using it as a Postgres database. But there are other features that you might find helpful when you're building and let's say you're testing features, and that's kind of how you do it. But happy to chat with you about it later, once we're done.
Any other question? Oh, good.
So,
and I'm running because I have to reach my Fitbit goal. So.
Okay, thanks. I was just wondering, do you see the process you're showing just now getting productized? So someone who doesn't really code can also build an agent that can send themselves the emails or something like that. I mean, it just feels like a super nice personalized applications that technically should be available to everyone.
So funny enough, every time I do this talk or workshop, everyone asks me the same question. It's hey, have you tried building this own thing and building it? And hey, the code is open source. It's it's simple to build. The first version, of course, if you want to build this into something more realistic, it will take more effort, more time, but it is very possible. So hey, if you want to go do it, by all means, go for it. It's GitHub. It's open source.
Awesome. One more question before we move on. Any other question?
We're good?
So I have a question, actually.
Yeah,
Can you talk about Neon, the database? What is the difference between Neon and the other databases?
Yeah, for sure. So we do manage Postgres. We have a generous free tier. You can start, you can have a database in a second. And we have a bunch of features that help you ship faster and with more confidence. So at a high level, you can kind of just see Neon as, oh, I just have a database. But once you become a power user, you can integrate into your workflow. So you can create a database for every preview deployment. This allows you to test schema changes if you're doing them. And it also auto scales, so you don't have to worry about that. And when we're building it, we really think about the developer experience. And all of our features essentially help you build better apps. So you don't have to worry about capacity planning, and it just auto scales. And yeah, you can get started for free. You can try it out. It's at neon.tech. But yeah.
Awesome. Thank you so much.
You're welcome. Thank you so much.
Cool. So next we have Yingjun. And while you set up your computer, Mahmoud, I just want to say that great that you are using GitHub Codespaces. So if you've never heard about GitHub Codespaces, go check it out. I use every day, either inside my VS Code or outside. If you've never heard about it, I need to tell you that it's life-changing. So thank you.
Hello, everyone. Can you hear me? Yes, definitely. Yeah. Cool. Today, thanks for having me here. And today I'll be talking about beyond Q&A, build event-driven agents with a streaming database. A little bit about myself. I'm not an AI guy. I'm a database guy. I don't know why I'm here. But I mean, to be honest, the organizer actually asked me about whether I can give a talk, and this morning I told them that can I say something about the database like Iceberg? Have you ever heard of Iceberg, Apache Iceberg? Yeah, probably some of the guys, you know that. Well, I mean, yeah, Iceberg is a big thing in database community, right? But I mean, they told me that, well, no, you cannot say anything about the Iceberg. You have to say something about AI. We only care about AI. Okay, and then, okay, anyway, so I told him that, okay, look, I will grab my colleague's slide deck and talk about some random stuff, okay? And I know that, well, most of you guys will probably, I don't know whether it's most or probably at least many of you guys are come here just because you are FOMO, right? And yeah, you are thinking about, well, your boss are asking about, okay, what's your AI strategy? Or you are looking for your next job and think about, okay, which AI company I should join, right? Okay, no worries, well, I'm just like you, and I'm a founder of Risingwave, and every single day I think about my company's AI strategy. Okay, I will talk more about that part. But well, I mean, the Risingwave, then let's talk about the Risingwave a little bit. I mean, I know that's why it's not a good place to sell my product because you guys are not looking for a database. But the Risingwave is a distributed SQL streaming database, and we open source in Apache 2.0 license, and have very adopted by thousands of companies worldwide. Some of them are like world's largest trillion dollar companies, and some of them like financial services, and yeah. But well, you probably don't really care. But anyways, so if you think about streaming database, well, if you think about like Kafka, PostgreSQL, like real-time data, then you definitely want to do something like stream processing, right? For real-time processing, and then probably you need to think about okay, whether we want to use something like Risingwave. Okay, and a little bit more about Risingwave. That is, well, I mean, what's the domains, right? Where we can get real-time data, right? We mainly get the real-time data from let's say, if you want to do stock trading, right? Well, stock trading is definitely a real-time data, right? Well, if you want to trade, you probably don't really want to trade on yesterday's data, right? So you only want to trade on today's data, and actually the last second's data, right? So, and probably last minute data. You never care about yesterday's data, right? That's a real-time data. And let's talk about financial service. Let's talk about the energy, right? Or probably logistics, right? You only care about the probably last minute data, and you never care about last year's data, right? So that's not quite useful. So for Risingwave or for any like stream processing systems, we only care about the real-time data, and we process the data in real time and give you like second level results. And then let's talk about AI. So yeah, that's my user journey. I mean, my AI journey. Where every single day I ask the colleagues, right? Well, what's our AI strategy? And people tell me that okay, probably we can build a vector database, right? And some people say that well, probably we can build a rack and index all indexes, right? Index all docs, right? And probably can serve our customers. And some people just say, okay, buy a bunch of AI tools. And yeah, we did buy a bunch of AI tools like Cursor, like Graphite. Well, have you ever heard of Graphite? Okay, basically it's a code review tool. And RunLLM, it's like how to say? Well, I mean a bot or agent for documentation. And even if you log into our website, you will find that we actually, for our documentation, I mean, it's like if you type in something in our search bar, you will find like it's an AI agent, right, for a doc. Actually, I also recorded a video, a promotional promotional video for one of our vendors, well, one of the vendors, and they asked me that you should never talk about call our system a bot. You should always call the system agent. Okay, never mind. So we adopt a lot of agents. And back to our, but when we use all these kind of agents, we found that there's a problem, right? Well, the problem here is that okay, it's really difficult to, I mean, it's really difficult to, how to say? Well, I mean, most of the bot agent is like a bot. It's like they only give right answers, or they only try to give you answers, right, based on questions. But in many cases, whenever we talk to our customers, well, they are like financial services. They probably do stock trading, or they probably do something like energy consumption analytics, or they probably do something like, okay, for logistics, they probably want to analyze, okay, what happened over the last 1 minute, right? Whether there's package missing, right? Or all these kind of things. They actually do not really have they were not ask about like, okay, check me, tell me, okay, what happened to this for the package, right? Well, tell me what happened to this transaction, right? Well, they were not like asked like that. They actually only care about, okay, whether what they really want to do is that they actually want to process events, right? Well, the events one by one. They do not really want to, okay, just call a function like a process events, right? Well, and tell the agent to give me an answer. What they really want to do is like event-driven experience. Like every single event comes in, I can trigger something, right? But the problem here is that, so, I mean, every time if you have an event, for every single event, if you call the if you call the OpenAI API, you find that well, it's too expensive and it's too slow. So what people really find what people really do is that they actually will build basically you still use the stream processing system or still use some data processing system, like no matter whether it's Spark, no matter whether it's like Flink, or no matter whether it's like Risingwave, to process the data before sending the true data into the OpenAI or invoke the OpenAI API, right? So here's the workflow. So for example, let's say that's what we have. Let's say that's what we hook up with the let's say the email, right? Well, I'll probably hook up with GitHub webhook, right? Then what people really want to do is that's right. They will not do things like, okay, for every single event I call OpenAI API. What they really want to do is that's what they actually have the filtering, right? Well, to do the processing first, and then sending to and then for certain events that they really care about, they actually invoke the LLM. So we found that's where this pattern is really popular in most of the logistic companies, energy consumption companies, where all the companies that we have a lot of events, or even companies like Uber. They actually really want to understand, well, I mean, what a user behavior look like, right? Well, they were not really ask the LLM that, okay, whether this transaction is a fraud. They actually will still use the database to do the processing, no matter whether it's Risingwave, no matter whether it's Spark, to do the processing before invoking the system, before invoking the OpenAI API, right? So yeah, this is the workflow, and basically it's like so. This is I call it we call it essentially more like a proactive agent. That is, well, I mean, for every single time we actually the agent behavior or the bot behavior or the bot answer always triggered by the events. But before triggering the events, we actually have the processing system to process the data. So let's talk about the use case, that is stock trading. For stock trading, for stock trading, typically people want to do probably join some data, right? Well, let's say the currency conversion along with the a transaction data. They actually want to join these two tables continuously and to process them. And let's say that's where if we want to have the AI agent to tell us that whether there's some fraud transactions, right? It doesn't really make any sense for people to send the transaction directly to an OpenAI API and to check whether it's fraud. So what people really want to do is that's what they actually write a SQL query and to process data. And the interesting part is that's where we found that many non-technical persons do not really know how to write SQL. So we found that essentially they actually use OpenAI or some other the LLMs to do the text to SQL translations. So one very practical use case in so-called proactive agent is that we found that recommendation system. So in the recommendation system, no matter think about Amazon, right? So if you log into Amazon, you will find that there are a lot of ads. they have ads because a lot of ads. They have ads because they actually track your behavior, right? Well, so essentially, we found that more and more people are actually websites actually using the ARM to make recommendations. What they do is that's where they will collect the data. Let's say that's where you are looking for Hacker News. I know that's where Hacker News doesn't really have have ads, but we'll think about if they want to promote you with some do some ads recommendation, what they will do is that's where they actually will track your behavior. But in the past, what the people really do is that's where they actually have certain kind of algorithm to detect, okay, what your behavior looks like, right? What kind of ads I want to promote to you. But these days, people really, what people does, we find that what people really does is that they will not set all these kind of rules. Instead, they will actually ask AI to find a strategy and to promote, to find the best way to promote their ads. So yeah, that's about the recommendation. And the other thing is about very similar to recommendation. We also find that people also use this same thing to do things like user feedback collection. Basically, every time a new user comes in and they found that okay, there's a new user feedback comes in, right? We can use ARM to detect okay whether it's like whether we should make some take some actions. For example, whether we should send a coupon to the users to prevent churns, right? These are the very useful use cases we found in the event-driven space. Yeah. Okay. Anyways, that's my talk, and we actually have a demo for this. And if you are interested in a demo, then you can just scan the code. Otherwise, I mean, if you are interested in Risingwave, if you're interested in stream processing, you can also scan for another the barcode. Okay. All right. Thank you.
Thank you. We have time for 2 questions, if anyone have. I have a comment, actually. Look, so I see all over LinkedIn with the new AI experts saying that Cisco is dead. Is Cisco dead?
That's a very good question. We actually have so basically I came from, before starting running a startup, I was at AWS Redshift. And if you never know Redshift, then think about Snowflake and Databricks. We were actually, Redshift is basically the AWS data warehouse. So I actually have a lot of colleagues working on these systems, and they actually know the text-to, they also build text-to-SQL. But the challenge here is that the main challenge of text-to-SQL is not about the model. It's actually more about the quality of your descriptions. Basically, you create a table, right? Well, let's say that if you're using Neon, we have a very good relationship with Neon. Neon is super cool, right? And if you create a table in Neon, the issue here is that you never write the comments to describe your table. So essentially, even if you ask a question in Neon, right? Well, ChatGPT tell me how to write this SQL, right? Well, the problem here is that it didn't really, the ChatGPT doesn't really understand what a table really means. And it could just give suggestions, or it could probably just guess based on a column name, right? So, which makes the quality of the translation very, very low, which makes it basically useless. So, but I mean, if you are diligent enough and if you write enough comments, I have to say that the quality can be significantly improved and it's really useful. So yeah. So anyways, well, if you run, if you find that your text-to-SQL doesn't really work, don't blame Neon, right, or some other databases, right? Well, think about whether you really write comments in your database systems or describe your tables. Yeah.
Awesome. Thank you so much. Thank you.